It's another math day with teacher Jenny here, and we are here for another video on solving rational inequalities. Now, this is now one example of solving rational inequality in which you've got there your pattern, right side is 0 and a single term on the left side. Now, notice here our left side here involves trinomial on the numerator and a binomial on the denominator part. So if this is the case, since we are going to equate our numerator and denominator to 0, so that would simply mean that we require the knowledge and concept of factoring trinomials in here. Now, if you're having trouble with factoring trinomials, you can scan over my videos. I have a video there on factoring trinomials. It's a guide and easy factoring trinomials in there. So kindly check that out. I'll be posting the link down below so you can check on that one later. So moving on to solving rational inequalities here, let's go and try to equate this one to our 0. So we'll start with the numerator. We have x squared plus 5x minus 6, equating that to 0. That would mean we can factor this out, and factoring this out, since we have here our number, which is negative 6, so we will be basing our factors on negative 6 and looking for possible factors of negative 6 in which that will lead to a positive 5 once you've added. So here we have the negative 6. One of the possible factors of negative 6 are the following. We have 1 in 6. Take note, we have this one as negative. So that means to say that the signs of your factors must be different. Now, the sign there will be basing on the middle term. Since that is positive, so that would simply mean that our factor that contains the positive sign in there will be bigger than or the bigger factor. So since I mentioned 1 and 6 there, between 1 and 6, the bigger factor is 6. So that would simply mean that this is positive and 1 will become negative. So there you go. Adding that up, that would simply mean that this is equal to 5 and that is positive. And looking at the middle term, we have indeed positive 5x in there. So writing your factors, we will be utilizing negative 1 and 6 in there. And we'll be attaching that one to the square root of x squared, in which we have that one as x. So x minus 1 and x plus 6 is now our factors for that negative 6, or the x squared plus 5x minus 6 in there. Once you've factored it out, you can start equating that to 0. And remember, you can equate each of the factors here to 0. So we'll have x minus 1 equal to 0. And the other one is x plus 6 equal to 0. So looking for x is now equal to 1. And x is equal to negative 6. Those are your critical numbers on the numerator part. Now, on the denominator, we can simply equate that to 0. Our x there is 3, but take note this is on the denominator part and we do not wish to make our denominator 0. So we are not going to let this be equal to 3 because that makes it 0. Once denominator is 0, the entire left side will become undefined. And that is what we don't want. So here we go with our critical numbers. We've got 3 critical numbers. So we are expecting that we've got 4 regions to test on. So testing the different regions here on the number line. So let's now move on to the next one. We have our x, which is equal to positive 1, and another x, which is equal to negative 6. And we still have an x, which is not equal to positive 3. So those are the critical numbers in which you are going to plot on the number line. Now, considering the sign of your inequality that's greater than or equal to, that means to say that those values we've obtained from the numerator, the 1 and -6, will have that one as shaded in graphing it on the number line. So we have here -6, and we have somewhere here +1, and we have +3. So again, +1 and -6 are coming from the numerator, and the inequality there is greater than or equal to. So we are plotting this one as shaded. Next, we go to 3, since that is coming from the denominator. Of course, that is not included, so that becomes hollow in plotting on the number line. So we are now separating your regions on the number line using this line here. Now, I normally use a line there from your critical number just to look back later on in writing your solution. You would notice that those numbers with the line there are the separator of your regions. Or to say it, they can be as the boundary of the regions in there. So we are now going to test out. This is region 1, region 2, region 3, and region 4. Now you may or you may not write the regions as long as you know which region or which part of your number line is your possible solution of your inequality. That is really fine. So let's move on in testing each of the region here. So we have here region 1. If I'm going to choose on -8 as my x value on region 1, I will be plugging that into my original equation. We have x squared, inequality, we have x squared plus 5x minus 6 over x minus 3, and that is greater than or equal to 0. So let's try to check that out. Okay, perfect. Next, we move on in plugging in, so we can have that one as -8 squared plus 5 times -8 minus 6 over -8 minus 3. Will that be greater than or equal to 0? So we have -8 squared, that's 64. Positive 5 times -8, that makes it -40. Minus 6 over -8 minus 3, that's -11. Will that be greater than or equal to 0? So we have 64 minus 40, that is 24, minus 6 over -11. So from that line on, you will really distinguish or determine whether this is true or false, because 24 minus 6, that gives off positive. And positive numbers divided by negative numbers, take note if they don't have the same sign, that will always lead to negative number. Since that is negative as the outcome of that statement there, that means to say that this is now false because our negative numbers cannot be greater than 0. So that is false. So that means we are having this out of the picture as one of the possible solution of our inequality. Now moving on to region 2. Region 2 here, we can just pick on x equal to 0 because that will be a lot easier. So we have here 0 squared plus 5 times 0 minus 6 over 0 minus 3. Will that be greater than or equal to 0? So 0 squared plus 5 times 0, that's 0. So we have -6 over -3. Will that be greater than or equal to 0? So from that line, we can really tell whether that will be true or false. Now looking at it, we have the same signs. So that means to say that becomes positive on the final answer. And positive numbers are always greater than 0. So that means this is now part of our solution since this is true. Next, we go to 3, testing that out. we can have our x here as equal to 2. And plugging that in, we have 2 squared plus 5 times 2 minus 6 over 2 minus 3. Will that be greater than or equal to 0? 2 squared is 4 and 5 times 2 is 10 minus 6 over 2 minus 3, it's negative 1. Will that be greater than or equal to 0? 4 plus 10 is 14 minus 6 over negative 1. Will that be greater than or equal to 0? Now looking at that, 14 minus 6 is 8. That's positive. And over negative, positive divided by negative, that will be negative. And negative numbers are not greater than 0. So this means that this is false. Let's move on to region 4 and getting a number here. Let's say x is equal to 5. And we do 5 squared plus 5 times 5 minus 6 over 5 minus 3. Will that be greater than or equal to 0? 5 squared is 25. 5 times 5 is 25 minus 6 over 5 minus 3 is 2. Will that be greater than or equal to 0? 25 plus 25 is 50 minus 6 over 2. Will that be greater than or equal to 0? Now looking at that one, we've got 50 minus 6. That's giving us positive number. Positive divided by positive is positive, and positive numbers are greater than 0. So this means that this is true. And 4 is part of the solution. So writing now the solution for your inequality in there, we have region 2 and region 4 as part of the solution. So we will be writing based on the boundary. Region 2 boundary is negative 6, and that is shaded. So that means we have bracket in here, and then we have positive 1, and there's shaded. That's also bracket. Since there are more than one region as part of the solution, we'll write the symbol for union. And then the boundary of region 4 is positive 3, but this is not included, that is unshaded. So parenthesis, moving towards positive infinity. So there you go with your solution of that inequality. So I hope you learned something from me. And I was so sorry with regards to the previous video regarding rational inequality part 3, there was a typo in there on the testing part, and one of my student mentioned that one. So I'm really thankful to Miss Oporto for really letting me see that there was a mistake in there. And again, I'm really happy that everybody is trying to take a look at my video. And join me again for my next video on the next topic in general mathematics, and that will be inverse function. So again, this is your teacher Jenny, always saying that math really is very easy. All you have to do is to practice more and look for patterns in solving that kind of problem. Okay, so I hope you are happy and safe at home. Goodbye.